1.1 Lines in a plane. What we should learn in this lesson. Find the slopes of a line. Write linear equations given points on a line and their slopes. We're going to be able to write an equation of a line given various ideas. Use slope-intercept formula of linear equations to sketch lines. We're going to use the slope-intercept formula to help us graph. And then use slope to identify parallel and perpendicular lines. First, slope of a line. Remember, slope of a line is how slanted the line is. And here you can see it's going up. This is a positive slope. If it was going down, it'd be a negative slope. We want to figure out how slanted this is. What incline is it? That's what a slope is. There's a couple of ways to find slope, but they all kind of start with the same way, which is first you want to find 2 points, x1, y1, x2, y2. You find the slope of that, which is to use the slope equation, y2 minus y1 over x2 minus x1. Also known as the change of y over the change of x. Sometimes you see that written like this, delta y over delta x. Delta just means change. So that's the same thing as that. The other way to do it is rise over run. It's the exact same thing, but a lot of times you see rise over run. Run is how much you went left and right. That's your run, this part right there. I always think you run that way, and then you rise, you go up or down. If you have to go up, positive. If you go down, negative. Now, the key thing about that is you go from left to right. If I was doing this, this would be my run, and this would be my rise. It's all about how you want to do it. The key is you got to find 2 points, and then either do the slope equation or do rise over run. Let's do a quick example. We want to find the slope of these two guys. If I have a line, I'm generally going to do rise over run. I'm going to pick 2 points. Let's say that point there. And let's say this point there. It's kind of hard on here because you don't see any other points, but I'll pick these two. And we're just going to try to go from one to the other. I got to go down. I went down 8. Since I went down, that's negative. And I went over 2. And then rise over run. Be negative 8 because up and down is rise or fall. And then run is 2. So I get negative 4. It's my slope. In this case, you have 2 points. If I see 2 points, I'm just going to do x1, y1, x2, y2. So my slope is going to be y2 minus y1 over x2 minus x1. Substitute these values in. Keep in mind, it doesn't matter which one's x2 and which one's x1. You could have done x2, y2, x1, y1. It just has to be in order. x1 goes with y1, x2 goes with y2. If I plug these in, negative 4, 4, 4, 2. So negative 4 minus 4, 4 minus, over here, they're both negative. Anytime they're the same sign, you just add them. Negative 4 minus 4, negative 4 plus negative 4 is negative 8. I just get more negatives. Anytime they're different signs, you subtract. 4 minus 2 is just 4 minus 2, 2. And I get negative 4 again. So that's how I find slope of a line. Now keep in mind, like I was talking about earlier, if the slope, if the line's positive, it rises. If you have a positive slope, your graph's kind of like this. If it's negative, it's going to fall. Or negative 4s here, they're going to go down because you're going to go down 4 and then over 1. That's not the right slope, but that's how negative works. If you get a 0 slope, I always think about slope is how do you walk? It's a positive slope. You're walking uphill, walking downhill. Slope of 0 means on the street, there's no resistance. That's a slope of 0. This is going up here to work harder. It's going downhill, working with gravity. 0 means there's no resistance. And then a line with the undefined slope, you can't walk it. Well, that's a vertical line. That's going to come like this. A straight line there. So that is no slope because you can't walk up a wall. That's what I always think about. This is a pavement, floor. Easy walk, slope is 0. No slope is you can't walk it. It's like a wall. These equations are generally x equals something. That's an equation for no slope. It's x equals, then that's where you get a vertical line. Horizontal ones are y equals something. Y equals some number. Next, point slope form of a line. Point slope form, I like to call this my equation maker. I use this to make equations. It's the easiest thing to make an equation. Point slope is exactly what it sounds like. It has a point and it has a slope. You can see right here. Here's my slope. And then your point is the x1 and the y1. That's your point. X and y are just part of the equation. When you get any equations with an x and y, you don't fill those out. What you do fill out for is x1, y1, and m. Let's do a quick example. In this exercise, find the equation of a line that passes through the given point and has an indicated slope. This is the easiest version you're going to get ever. You go, okay, I want to make an equation. Anytime I want to make an equation, for me, generally, you want to use point slope form. I'm going to do y minus y1 equals mx minus x1. And then we're just going to substitute in our values. This is x1, y1, and this is my m. 1 goes there, negative 3 goes there, 6 goes there. You get y minus 6 equals negative 2x. Double negative, 2 negatives make a positive, x plus 3. And you're done. Unless they specifically say put it in slope-intercept form, which technically we haven't talked about yet. That's it. If they say make an equation of a line, there you go. That's an equation of a line. The next, sketching graphs line. When you want to sketch a graph of a line, that's when we're going to use slope-intercept form. That's best for graphing. The slope-intercept form is my grapher. So when you want to graph, you want to do slope-intercept form. In that, because it tells you everything you need to graph, it gives you your slope. M is slope, which is just rise over run, delta y over delta x. And then B is a y-intercept, which is exactly what it sounds like. It's your first point. It's where you start. Let's do a couple real quick. This one, if you notice, it's not in slope-intercept form. But we got to make it look like slope-intercept form. We got to get y by itself. So let's subtract 2x, add 9, and get 3y equals negative 2x plus 9. And we want to get y by itself. We're going to divide by 3, divide everything by 3. And I get y equals negative 2x over 3 plus 3. Now it's in slope-intercept form. You could graph it. First thing I'm always do is find my y-intercept, which is this guy right here. I'm ready to start 0, 3. That's my y-intercept right there. And this is x and this is y. You start there, 0, 3. And then next we're going to do the slope. So the slope here is negative 2/3. The thing next to the x, the coefficient of the x. All we're going to do is from that point, our first point there, we're going to go down 2, rise over run. In this case, fall. We're going to go down 2, and then we're going to go over 3 right there. And if you want, you can do it one more time or a couple more times, and then you can connect the points. And that's how you graph a line, just like that. Before we go on to the next one, let's go back up here. If I wanted to graph this, right now, I really can't graph this. It's just an equation. If I actually wanted to graph it, I would put it in slope-intercept form. Distribute, and I get negative 2x minus 6, and then I would add the 6 to both sides. Hey, those cancel out, and I get y equals negative 2x. Now, how do I graph that? The way I graph that is I just picture this like it's a plus 0. So this is my y-intercept at 0, and then my slope is 2. So your slope is negative 2. You always want slope to be a fraction. Put it over 1. I'm going to go down 2 over 1. Lots of negative slopes today. I'm going to go down 2 over 1. Connect those, and there's your graph. Okay, let's grab this one before I'm done. So 3x plus 7 equals 0. We want to solve for x. So let's minus that 7. Normally we solve for y, but there's no y here. So it's only the one variable we have by itself. Divide by 3. X equals negative 7/3. The way we graph this, we go where x is and go for negative 7/3, which that's the same thing as what? Negative 2 1/3. It's a little past negative 2. We're just going to estimate it there. And I always say follow the tally mark. Normally when you do a tally mark here, you do it like this on the x's and go up and down. And that's my graph of x equals negative 7/3. This has no slope, it's a wall. And that's why you have no m here, because no slope. Couple key things to remember. We did point slope form. That's the thing I used to make an equation. We did slope-intercept form. I like to use that to graph. There's also the general form, which is ax plus by plus c. You just have everything on one side. We have vertical line. We talked about that earlier. X equals horizontal line, y equals. And then slope-intercept form and point slope form. Last main thing, parallel and perpendicular lines. Parallel lines are lines that have the same slope. They never cross. Something like this. They have the exact same slope. M1 equals M2. Their slopes are negative reciprocals. So you got to flip the slope and change the sign. Probably the best example, if my slope of 1 was 3, my perpendicular, that's a perpendicular symbol, upside down t, would be flip it and change the sign. Make it 1/3 and then change the sign to a negative. You always flip it and change the sign. Perpendicular slopes cross that at 90-degree angle. Those are perpendicular slopes. So M1, M2. We want to do two things here. We want to find the equation of a line that goes through this point and is A, parallel to this line here, parallel to that. Then we're going to do the same thing. We want it to be perpendicular. For step 1 though, if you want to find the equation of a line, anytime I want to find the equation of a line, I use point slope form. So we're going to do y minus y1 equals m x minus x1, like that. And we have our x1, y1. They gave it to us. That's going to be negative 3, and that's going to be 2. What we do not have is the slope. Now, some people might think it's, oh, it's the thing next to your x, it's your 1. It's not. That only works when we're in slope-intercept form. Here's my x, here's my slope, but it has to be in slope-intercept form. We got to get y by itself first. First step here is put this in slope-intercept form. We're going to get y by itself. Subtract that x from both sides, and we get y equals negative x plus 7, which makes our slope negative 1. In this case, we want it to be a parallel slope. Parallel means the exact same slope. They have the same slopes, and use that slope, negative 1. And normally, I would say we are done, but it does say put it in slope-intercept form. So they want this in slope-intercept form. We're going to simplify a little bit. So the only time I have to do that is when they specifically ask me for that. And then I'm going to add 2 to both sides, and I get y equals negative x minus 1. Now we're going to do the same thing for the perpendicular one. They want an equation of a line. Y minus y1 equals m x minus x1. We have our point already, our x1, y1, done. And now the slope. Parallels use the same slope. The perpendicular slope, negative reciprocal. So we're going to flip it and change the sign. We're going to flip it, make it 1 over 1, and we're going to change the sign from a negative 1 to a positive 1. So we just get 1. That's our perpendicular slope. And now they want a slope-intercept form. Just simplify it just real quickly. Distribute the 1, and then move over that. And here we go. We found the equation of a line that's perpendicular to the line they gave us. And that's it. That's the lesson.